Hi there. My name is Austin Dial. It's February 22nd and about 9:41 p.m. This is a Monday, so this project is being submitted a little bit late. But I was having some problems that I wasn't really able to solve on my own. It was a little bit frustrating, but I figured it out. It's all ready, and in the process, I learned a few tricks that I wouldn't have if it weren't for these problems. So in a way, I'm thankful for them. So I'm just going to go ahead and execute it. You can see that I named it A4. That's assignment 4. Now, just like all my assignments, pardon me, I like to print the actual circuit just for reference. If anyone's actually using this, they're going to want to see what they're working with. Just as in previous assignments, I have a circuit.txt file, which literally just has this, tabs and new line, escape characters and all. And then I just have a function which reads and prints the characters to screen until it reaches the EOF character, end of file, in which case it just returns 0 and exits, leading to the setup function, which brings us to filling out these values. I'm just going to throw in just 10 for all of them, just to give a sense for what the program looks like. We can see here that it gives everything in milliamps, just as requested. And based on our circuit analysis, which you can see in the appendix, we can see that, let's see, that's 285.714. We'll add that with I2, 857.143. Wait, was that 143? Yeah, that's right. We can see that's 1142.857. 1142.857. So I1 mesh current plus I2 mesh current equals I3, which means that these results are, pretty accurate. Then again, there are an infinite number of numbers which will add up to 1142.857, but it's unlikely that this program generates all of them and then gives us one. That would be ludicrous. On top of that, you can go ahead and just analyze for yourself and see that the results are quite factual. Let's just give it random values. Let's do, let's see, actually, hang on a second. I know that Dr. Mia tested it under very specific conditions, and let me actually run those conditions for demonstration purposes. Alright, you should be able to see inside the screen, we ran 30, 120, 60, and I'm clever enough to make this thing transparent so we can look through it and read what's underneath it. It's 20, 60. Now for ohms, we've got 4, 5, 10, 30, 10. Alright. There's the result. I am 100% confident that if you add I1 and I2, you will get I3. Those are the conditions that he tested for mine. One of the tricks that I learned while I was doing this, I really wanted to see what the determinants were doing before they were being processed to find the currents. And to do this, I created something called verbose mode. Or at least I used it, so I can actually send arguments via the int argc, char, pointer, argv array, arguments sent to main, and in doing so I can change the program's behavior. So it tells me what function it's in, what's happening, for instance function called, printing file contacts, closing file access, contents, pardon me, populating E. Now we can just run this through. Let's keep with the same numbers, 120, 60. Populating R, just do random stuff, 57, let's do that, and 1 just for humor. Now what it does is it actually prints the determinants of the matrices before it uses them to calculate the mesh currents. This is actually incredibly important because I can find, well, let's see, the program thinks the determinant A is this, what is the determinant by hand? And if the two of them match, then we know that it's good. We can see here that it's actually just waiting for me to send it a value. It's actually just going to send an integer to temp, and it has no consequence. Then it actually runs through the rest of the process and gives us the mesh currents before exiting the main. This is really nice because it allows you to run it like this, where you don't really have to worry about getting a bunch of information that you really don't need, but at the same time you can also run it in verbose mode and get a lot of information that's quite useful for the developer. So I really like that feature. I hope that you enjoyed. I hope that you find the reports thorough as always. Again, good luck with your grading. I'm sure that you're quite busy. Everyone had tests these past few weeks, so I hope that you did well. Perhaps I'll see you in the lab one day. We have yet to meet. Good night.